Hello champignons, today we're going to carry on our study of index laws and move on to fractional indices. Now the first fractional indice related problem I'm going to show you is this one here. So I'm going to start off with 9 to the power 1 half, and I'm going to multiply that by 9 to the power 1 half. So there we've got a base of 9, it's being raised to the power 1 over 2. But what I'm going to do with this one is say, well, I've got the same base being multiplied by itself, so I can simplify those powers by adding them together. So I've got 9 to the power of 1 half plus 1 half, like this. And a half plus a half just equals 1. 9 to the power 1 is just a straight up 9. Okay, but what we're going to think about here is, well, I've got 9 to the power a half. I've multiplied it by 9 to the power a half, and it's given me a result of 9 just here. Another way we can think of, well, what do we usually think about when we say, well, what number multiplied by itself will give me this number? Usually we think about those as square roots. So say the square root of 9 multiplied by the square root of 9 is going to give me, it's 3 times 3 rather, which is going to spit out 9 for this one. So what I want to point out there is that it appears on a surface level at least that 9 to the power 1 half is equal to the square root of 9. And what I'm going to do there as well, I'm just going to chuck a little 2 in front of that square root of 9. Every time you see a square root symbol without a number there, it actually means that there's an invisible 2 there. Square roots are such a common operation, we don't usually put the number 2 there, but it just means we're finding the second root of 9. So that's something to keep in mind. What I'm going to do now is do something kind of similar, but I'm going to do 8 to the power 1 over 3 this time. I'll multiply that by 8 to the power 1 over 3, and with a growing sense of inevitability, multiply that by 8 to the power 1 over 3. So for that one, we've got the same base this time as well. We've got a common base of 8. I can simplify the powers by adding them together. So 1/3 plus 1/3 plus 1/3. It's going to give me 8 to the power 1, which is the same as 8. Now, again, we've multiplied a number here by itself 3 times, the same number by itself 3 times, and it's spitted out an 8 for us. That's kind of the same as saying, well, if we found the cube root of 8, and we multiplied it by the cube root of 8, and then multiplied that by the cube root of 8 as well, and saying, well, what number multiplied by itself 3 times will give me an 8? But multiply that same number again 3 times, it's just going to spit out what we started with, which is an 8. And their cube root of 8 is 2, because 2 times 2 times 2 is 8. So 2 times 2 times 2. 2 times 2 is 4, and then 4 times 2 gives us 8. So that works as well. So what I want to point out there is that we've got the cube root of 8, which appears to be the same as 8 to the power 1 over 3. So, like we had for our first little example, that relationship between this 3 and this 3 is pretty significant. Same with 9 to the power 1 over half and it being the same as the square root of 9. Okay, so this gives us a little handy summary of fractional indices. Just get rid of a few of these little highlights just here. So we can summarize it like this. So a to the power 1 over n is the same as the nth root of a. And that's what I've got this little note for here on the side. If we've got a number in front of the square root and then something, I say square root, really it's just the root. If we've got a number in front of that, we read that as the nth root of whatever we have underneath the root symbol. So a couple of examples there. If we had 5 to the power 1 over 2, that's equivalent to the square root of 5. Again, we don't need to write that 2, but I will do for today. The next one, which is 6 to the power 1 over 3, that gives us the cube root of 6, so that's how we can write it in surd form. And then the last one there, 10 to the power 1 over 10, is really just the 10th root of 10. So what number do I need to multiply by itself 10 times to spit out a number 10? So there we're going from fractional indices across to what we could call surd form for this one. So we've got things in terms of square root signs or root signs there. Okay, now this is where things get a little bit more spicy. What I'll get you to do first is consider 4 to the power 3 over 2. So it's not 1 over something. Now we've got a number in the numerator as well as the denominator as well. So what I could do for this one, I could write 4 to the power 3 over 2. I could think, well, I know that if I'm finding something to the power 3 over 2, I can do this in a couple of different ways. So I can either say, well, 4 to the power 3 over 1 times 1 over 2, because that gives me 3 over 2. That would end up looking like this. So 4 cubed and then finding the square root of that. That's kind of interesting. The other way that I could rearrange that would be to say, well, 4 to the power 3 over 2. I could do that the other way around and say, well, 4 to the power 1/2 times 3. And that's kind of the same. It just looks a little bit different. That would give us the square root of 4. And I've raised the whole thing to the power 3. So what you'll notice there is that we've got two different outputs for this one. And the reason it's important to point this out to you is because they're actually the same value. So the order doesn't matter when we've raised something to a fractional power. We can either have it raised to the power of whatever's in the numerator and then find the nth root from the denominator, or we can do the nth root first and then raise it to the power that's in the numerator. So in terms of a summary, this looks a little bit like this. So if you've got a to the power m over n, you can either have that as the nth root of a raised to the power m, or you can have it as the nth root of a raised to the power m. They've got the same value to them. And to prove it, I'm going to do these two problems both ways. So if we've got 8 to the power 2 over 3, using the left-hand side method, I'm going to say, well, what I want here is the cube root of 8, and then I'm gonna, hang on, I can write that a little better. I'm gonna find the cube root of 8 and raise that to the power 2. Cube root of 8 is 2, and 2 squared equals 4. Cool. For the next one, I've got 8 to the power 2 over 3 again, but this time I'm gonna say, well, I'm gonna do 8 squared and then find the cube root of this. 8 squared gives me 64, and finding the cube root of that, so what number multiplied by itself 3 times will give me 64. 4 times 4 gives me 16, and times 4 gives me 64. So my cube root of 64 is 4 here. Now the reason that this is really important is that you might agree that this was probably the easiest way of finding that, like if you were looking to evaluate the expression. In another situation, this might have been the easiest way to do it. What I'm trying to point out here is it doesn't really matter which way around you go, but you've just got to look for what might be the easiest for you to do mathematically. Like in a test situation, you want to be trying to make things as easy as what it possibly can be for you and not overcomplicate things. Okay, these ones we're going to go from surd form across to index form. So these are all nice and easy, and we'll do some harder ones in the next video. First one is the cube root of, the square root of 10 we want to convert to index form. So there we're going to go 10 to the power 1 over half. Happy days. The next one, we're finding the square root of 5a to the power 3. What you could do for this one is think of that as 5a to the power 3, and then you're raising the whole thing to the power a half. This is a good example of combining fractional indices and the index laws that you know already. So now we've got 5 to the power 1/2, and then a to the power of 3 times a half, which will be 3 over 2. And again, because we want this in index form, we don't then convert that back to the square root of 5 and then the square root of a cubed. We just leave it like this because we want index form for these ones. And then for the last one, we've got 2 multiplied by the 4th root of b to the power 5. The 2 that's in front is completely separate. We're just multiplying the 4th root of b to the power 5 by 2. So we don't involve 2 in our endeavors with this one. We're just going to say 2 multiplied by b to the power 5 over 4 for this one. So don't get sucked into getting the 2 involved with things, because the 2 wasn't invited to this particular party. Okay, in surd form for these ones, so 4 to the power 1 over 6, that's just going to be the 6th root of 4, as in what number needs to be multiplied by itself 6 times to give us 4. And for the last one, 5 to the power 2 over 3, I'm going to write that as 5 squared and then finding the cube root of that. But if you'd said the cube root of 5 squared, that's fine too, but generally speaking, the fewer brackets, the better with these ones. So for me, the answer on the left would be the way to go. And then finally, we're going to evaluate these without a calculator. So remember, whenever we see the word evaluate in a question, it means we're not just simplifying or something similar to that. We need to spit out an actual number as part of our answer. So 9 to the power 1 over 2. That's the same as finding the square root of 9, which is, of course, 3. With evaluate questions, you're going to expect to be finding the root of a cube or a square number or something like that. So for this one, we're finding the cube root of 8, which is 2, because 2 times 2 times 2 will give us 8. The next one's a little bit more funky. We've got to combine what we know about negative indices as well as fractional indices. So 36 to the power negative a half is the same as 1 over 36 to the power a half. We know that because anything raised to a negative power can be rewritten as 1 over the same base raised to the positive version of that power, or I guess the absolute value of that power. So now we've got 1 over 36 to the power a half, which is 1 over the square root of 36, which is, of course, 1 over 6. And because we're evaluating, 1 over 6 is still a value. We don't need to convert it to a decimal or do anything else silly with this one. That's our answer. It's fine the way it is. Okay, now it's on to the next video where we'll put some of these skills into practice with some more complicated problems.